can you solve this math challenge? Here's the question. If 2 raised to x plus y plus 2 raised to x minus y equals 10 and 2 raised to x plus 2 raised to y equals 6, then what is the maximum sum of x and y? You can pause this video if you want to give this problem a try. And now, let's answer this question together. So, our goal here is to find the maximum sum of x and y, given that 2 raised to x plus y plus 2 raised to x minus y equals 10 and 2 raised to x plus 2 raised to y equals 6. So, let's begin. First thing is we need to get this equation, 2 raised to x plus y plus 2 raised to x minus y equals 10. Now, let's use some laws of exponent. If we have b raised to a plus c, this is equivalent to b raised to a times b raised to c. So, 2 raised to x plus y can be written as 2 raised to x multiplied by 2 raised to y. Same thing as this number 2 raised to x multiplied by 2 raised to negative y. Now, notice that we have a common factor of 2 raised to x, so we can factor out 2 raised to x. This will give us 2 raised to x multiplied by 2 raised to y plus 2 raised to negative y. Now, let's use some laws of exponent. If we have b raised to negative a, it is equivalent to 1 over b raised to the power of a. Or if we take the reciprocal of a number having a negative exponent, then the exponent now becomes a positive if we take the reciprocal. So, 2 raised to negative y is simply equivalent to 1 over 2 raised to y. Now, let's simplify the expression inside the parentheses. So, 2 raised to y plus 1 over 2 raised to y can be written also as 2 raised to y quantity squared plus 1 all over 2y. Now, we don't want fractions in our computation, so let's multiply both sides by 2 raised to y. So now we have 2 raised to x times 2 raised to y quantity squared plus 1 equals 10 times 2 raised to y. Now, at this point, let's use the second given equation, which tells us that 2 raised to x plus 2 raised to y equals 6. Now, let's get the value of 2 raised to x. What we're going to do is to subtract 2 raised to y on both sides. So 2 raised to x equals 6 minus 2 raised to y. Now, what we're going to do here is to replace this 2 raised to x with 6 minus 2 raised to y, like this. So now, our equation now is in terms of 2 raised to y. So what we're going to do here is to distribute 6 minus 2 raised to y to 2 raised to y quantity squared plus 1. We will use chunk method here. So we have 6 multiplied by 2 raised to y quantity squared plus 1 minus 2 raised to y multiplied by 2 raised to y squared plus 1. This is called chunk multiplication. So by the way, you can use Pearl method if you want. And I assure you that we get the same result. Now, let's multiply. 6 multiplied by 2 raised to y quantity squared plus 1. This will give us 6 times 2 raised to y squared plus 6. Now, let's distribute negative 2 raised to y to 2 raised to y quantity squared plus 1. This will give us negative 2 raised to y cubed minus 2 raised to y. Now, let's simplify more. Take note that we have a common term on both sides. We have 10 times 2 raised to y and negative 1 times 2 raised to y. If we subtract 10, 2 raised to y on both sides, we get negative 11 times 2 raised to y on the left side. And the right side is equivalent to just 0. Alright. Now, let's rearrange some terms a little bit. So, the exponent of 2 raised to y is in decreasing order. So, and now we have negative on our first term. So, to eliminate this negative, let's multiply all terms by negative 1. So, to make this positive, if we do that, we get positive 2y raised to 3 minus 6 times 2y raised to 2 plus 11 times 2 raised to y minus 6. Now, this 2 raised to y is very annoying. So, let's replace this with another variable. Let's call this as n. So, we need to replace all 2 raised to y with n. So now we have n cubed minus 6n squared plus 11n minus 6 equals to 0. Now let's focus on this equation. Now one way to answer this question is to factor this cubic equation, but how to factor this cubic. Now, one way to notice here is if we add the coefficient, we have 1 minus 6 plus 11 minus 6. This is equivalent to 0. So, when we add all the coefficient of a polynomial and it is equal to 0, then technically, n minus 1 is a factor of this polynomial. So if we do that, if we factor this, we get n minus 1 multiplied by n squared minus 5n plus 6. Now, n squared minus 5n plus 6 is definitely factorable. This can be factored also as n minus 2 multiplied by n minus 3. Now, the factoring process is an exercise for you. And now, let's continue. Let's focus on this factored form. Now, since it is equal to 0, therefore, we can say that at least one of them must be equal to 0. So we can say that n minus 1 equals to 0, n minus 2 equals to 0, or n minus 3 equals to 0. Now, let's solve for the value of n in this 3 equation. On the first one, if we add 1 on both sides, we get the value of 1. On the second equation, if we add 2 on both sides, we get 2. On the third equation, if we add 3 on both sides, we get n equals to 3. Now, take note that n is equivalent to 2 raised to y. So, all of this n becomes 2 raised to y. Now, at this point, we don't really care to the value of y because we want the value of x plus y. So, what we're going to do here is to consider the second equation, 2 raised to x plus 2 raised to y equals 6. Now, we know 2 raised to y equals 1, so 2 raised to x must be equal to 5. There's nothing more. We add to 1, we get 6. So, therefore, 2 raised to x must be equal to 5. On the second case, if 2 raised to y equals 2, if this number is 2, then 2 raised to x must be equal to 4. Alright? And on the third case, if 2 raised to y must be equal to 3, then definitely 2 raised to x is also equal to 3. And now, don't forget, because our goal here is to find the maximum sum of x and y. And in order to get the sum of x plus y, what we're going to do here is to multiply those two equations, because if we have b raised to a plus c, it is equivalent to b raised to a times b raised to c. So when we multiply 2 raised to x and 2 raised to y, this will give us 2 raised to x plus y. That's what we want, the sum of x and y. So let's do that in these 3 pairs. So in the first case, we have 2 raised to x plus y equals 1 times 5. On the second, we have 2 times 4. On the third case, we have 3 times 3. Now, let's simplify. 1 times 5 is 5, 2 times 4 is 6, and 3 times 3 is 9. Now, to get the sum of x plus y, take note that when we have a number a, it is equivalent to b raised to logarithm of a to the base of b. This is a good identity that we can use in this kind of problem. Now, using this identity, we can now rewrite 5, 6, and 9. And if we do that, we can now solve for the value of x plus y. Now, let's do 2, 5. This 5 can be written as 2 raised to logarithm of 5 to the base of 2. Why we choose 2? Because the base on the left side is 2. Now, we can do the same thing on the second case and the third case like this. Now, take note that we have 2 equal expressions and we have 2 equal bases. Therefore, their exponent must be the same. So we can say that x plus y equals logarithm of 5 to the base of 2 equals logarithm of 6 to the base of 2, and x plus y equals logarithm of 9 to the base of 2. And now, technically, we want here the maximum sum of x and y. And definitely, the maximum sum of x and y must be equal to logarithm of 9 to the base of 2. Therefore, our answer to this question, what is the maximum sum of x and y, given these 2 equations, and our answer is logarithm of 9 to the base of 2. And as always, we are done.